Record this a different way, you people who are watching. So I'm hoping that it's recording because I have to be able to flip back and forth between these two screens. So, 8.2, it is recording. It's recording because I'm recording it a different way. So you just be quiet. Okay? It's recording. So, 8.2 is statistical experiments, okay? And this is going to involve things called simulations. Okay? Simulations are beneficial in the stats world to gather data without having to do a whole lot of work. So we will see examples in here that are like, I want to know the death rate of something, okay? And we look at previous data, just wait. We look at previous data called the theoretical probability, okay? So in theory, in the past, the death rate of something has been this, and we run a simulation. Now, it's good to run a simulation because actually killing those people off would be illegal, right? So we run a simulation instead.
Not really.
That's how this works. So a simulation is just like a trial run. You guys have been in simulators before probably, or like in video games where you're like in a car and you're running a simulation. I think they did one of these in the gym where you're in a car and it like simulates you getting into an accident and like rolling the car over. Or no, it was a simulation for drunk driving.
Kyle does
Wasn't there a simulation for drunk driving?
Right?
No, it was for
Kyle plays like
getting
he's
hit by a train.
simulator.
Getting hit by a train? Okay, something like that. But it's a simulation because actually killing you off would probably not be a good idea, right? So we run the simulation so that you can see what that feels like.
People on the world, we could sacrifice a billion of them and run the simulation with real people.
Right, sure. So, simulations is what we're doing in this section. And what I want you to look at is this box that we have right here. We're going to look at a probability model which involves a theoretical probability, which is what happens in theory, and an experimental probability. And there is a difference between the two. So, theoretical probability, circle this guy, is in theory what should happen. We're looking at tossing a coin and we want it to land heads up. In theory, what percent of the time should it land heads up? Right?
49.9.
50% of the time. 50% of the time. But if I run an experiment and I toss 10 coins, does that mean exactly 5 of them will come up heads?
No.
Not always. In this case, they did that experiment and they said out of 10 tosses, how many came up heads? 3. So their experimental probability was 30% rather than the 50% that it was in theory, right?
You know,
experimental versus theoretical is not the same always. Sometimes it will be, but sometimes it won't.
one of the sides of a quarter is actually heavier than the other.
Right.
So it's
Right.
Actually, not 50.
So it's not actually 50-50. I get that, but we're gonna what?
One shot above the rabbit, one shot below the rabbit, and the third guy screamed, "We got him!"
You're so funny. You're so funny. All right, so example 1 and example 2 go together. We're going to design a simulation that reflects the things that we're talking about. Okay, so Eloy inspects bike frames. What's a bike frame?
It's
bike
like the
frame.
metal piece on your bike.
Like the metal piece that holds the tires on. That's the bike frame, okay? As they come through an assembly line. From previous observation, he expects to find a weld defect. Weld defect. That means something that's not welded together properly. A weld defect in 1 out of every 10 frames. That means 1 over 10 are the chances of having a weld defect. That's 10%, right? 10% of the time it's going to have a bad thing happen with it, okay? And there's another type of defect, which is called a design defect. Okay, so the design is wrong. Maybe the color is not right, or there's a scratch on the outside of it and the design is all messed up, and that happens 1 out of every 20 frames that he inspects. Okay,
You're running a factory where
I know it's not very good. My percent is really bad. My percentages are really bad. Okay, so we're talking about defects here. If I run 20 bikes through, how many out of those 20 will have one of those different types of defects? If I run 20 bikes through,
3 out of 20.
3 out of 20. Okay, so let's look at this. This is what Jake Boniface was really brilliant this morning. He's like, hey, 3 of them are defective. How did you get 3 of them defective? If I get a common denominator of 10 and 20, what will that be? 20, right? 20. Okay, this will stay 1 over 20. But if I find a common denominator, what's 1 over 10 in terms of 20? 2. If I add those 2 together, that means 3 out of 20 are defective, right? Okay? So what we're going to do is we're not actually gonna like put bikes on an assembly line because that would be very costly and very time consuming for me. So what we're gonna do, 15%, right? What we're gonna do is we are gonna actually run this as a simulation, and I'm gonna do what's called a random number generator. But we've got to set some ground rules beforehand. Okay, here's my ground rules. Ground rules. Okay.
Numbers can only be 1 through 20.
The numbers can be 1 through 20.
3 or lower is
1 through 20. Okay, let's talk about 3 or lower. So, if it is the number 1 or the number 2, it is going to be a weld defect. If it is the number 3, it's going to be a design defect. What happens if it is a number 4 through 20?
It's okay.
It's okay. There's no defects at all. But do you see how we reflect the 1 out of 20, the 2 out of 20, those type of things for our numbers? What's up?
You know that's impossible to program a random number generator because machines do what they're told and it's impossible to create.
It's impossible for it to be completely random. I get that. Yep.
So this is just semi-random.
Right. It's as random as you can get. Yeah. So,
really random?
do you understand why we're choosing numbers 1 through 20?
How so?
1 through 20, and then it's going to choose numbers for me, right? 1 through 20. Okay, we're going to run this 100 times to see what our results are, okay? So, Caden, just a minute ago, said 15% are defective, right? I have a 15% chance of getting defect, right? 15, because 3 out of 20 is 15%, okay? 15% of all the bikes going on the assembly line have some sort of defect, okay? Don't even. Here's my random number generator.
Don't even need
And,
it.
yeah, you. And what I'm going to do is, you guys have access to this random number generator because you're going to need it for your homework assignment. It is on the Google Classroom page, so if you got an email from me, that's what it was. And it has this thing down here, and what you're going to do is you're going to scroll all the way down to the bottom, and we're going to edit the settings, okay? So our minimum number that we want to generate is the number 1. Our maximum number that we need is the number 20 because we're running 20 bikes through, okay? Or we're doing 20 different things. We're actually going to run 100 bikes through because we're going to look and see over time 100 bikes to see what's happening here. I want to make sure that it includes duplicates because if it doesn't include duplicates, it's going to just give me the numbers 1 through 20 again. It's not going to give me like a 2 happened 4 times, a 7 happened 3 times. It's not going to give me that, okay? So you want to make sure that duplicates is always clicked on. And we're going to run it. Here we go. I hit rerun and I go up to the top, okay? So, looking through those numbers, if it's a 1, a 2, or a 3, then that means it's defective, okay? We said weld defects. I'm going to go over here. If you guys can look over here onto the side, I'm going to try to have these screens going on at the same time. Let me move him over. Weld defects occurred with 1s and 2s. A design defect was a number 3. So let's go through and let's look at here. And let's count up all the 1s, just the 1s and 2s. Just the 1s and 2s. So top row, none of them. There's a 2 here on the second row. There's 1. 2, 3, 4. In the first 50, there's 4 of them, yeah? Okay, then I go down to the 60s. There's 6 here. None here. None here. Let's go down to the 91 through 100. So far we're at 5. Am I counting this right? How many more? 6 total, right? Because there's a 1 there on the bottom row. So 1s and 2s, there are 6 of them. So I'm going to put tally here. I'm just going to put 6. Okay, there's that. There was only 1, 2. Okay, now let's count up the number of 3s. Let's go back to the top. I wish I could make this, I bet I could make it smaller, but that's okay. 3s. On the top row, there's 1 3. There's 2 in this, there's another 1 in the second row. There's 1 here. That's 3. Then we have none, 4, 5 in the 6th row. None in the 7th row. Let's go in the 8th row, so we're at 5 right now. Okay, the last 2 rows. There's 6, and that's it. That's it. Okay, so 6 number 3s. We have just as many 3s as we have 1s and 2s, which is kind of weird, but anyway. So the frequency that this guy is occurring. Oh, and then how many didn't have defects?
88.
How did you get 88?
I'm big brain.
Because you're big brain. There's 12 of these, and we did 100 of them, so that means 88 don't have defects. So it is a 6% weld defect, a 6% design defect, and an 88% no defect. So we're 88% good, right? Okay, in actuality, I'm going to split this down the middle. This was the experiment, and in theory, let's go over here so you can see. In theory, what percent had a weld defect in theory? 10%. What percent in theory had a design defect? 5%, because it was 1 out of 20, right? 5%, and what percent was good?
Lots.
85%, right? Okay. So we had more weld defects than we thought, but we had less design defects, right? Okay. And we're doing a little bit better than what we thought in theory. 85% good in theory, but 88% in all actuality, okay? So, difference between experimental and theoretical probability. We designed this simulation because it's cheaper for me to just look at, right? Okay? Really, these two are going to, the experiment and the theory are going to be relatively close to one another, okay? But keep in mind that they won't always be the same. This morning when we ran this, it was exactly the same for both of them, and I'm like, oh, I was hoping it wasn't the same because then it made it look like they're always the same. But anyway, so let's graph our experimental ones on this chart over here. So weld defect, we had 6%, not 60%, 6%, which is going to be like all the way down here. Less than 0.1, right?
You know who
Design,